token is a bad guy. So what is the meaning of bad guy? Last time we tried to simulate in our mind what is the implementation of string token. So implementation of string token has a problem that you first time give in a string as a first argument. The next time you don't. You just put in now, and then it will automatically know where the last time we stopped at a particular string. Let's say the first character is A and then space B space C. Then it was A and then stop at the space, and then B stop at the space. So string token is just like magic. And magic is actually done by one thing. There is a global variable. Maybe it's not global, it is malloc. I don't know, okay? Because I didn't look into the source code of string token. And this guy caused such a problem. Last time I stopped at this problem. If you can't remember what happened, I will run it again. But before I run it again, you can see I input two threads with two different arguments. So the two different arguments is one is thread 1 says Linux is a cool operating system 1. Another is thread 0 says Linux is a cool operating system 0. So they have different contents. If you string tokenizing it based on space, okay, it's based on just one space. So it will break into two different groups of token, right? You have one group of token from one thread, and other groups of token from another thread, okay? But the output is not. The output seems to be interesting. It only gives you one group, and which group it is? It's not thread 1. Based on here, you know that it's from thread 0 group, okay? So what can I understand from this? I can only guess, okay, the later thread let's start executing. Okay, so this is a later thread that start executing, right? Thread 0 print out is later than thread 1. I know that, okay, thread 0 is a slower guy, and it takes the chance, just like something being shared, like mutual exclusion. If you're the later guy, you would take the control of the system. And last time we already emulated what happened during we call a string token. Actually, you will put a pointer address inside this global data structure. Okay, the pointer address is a string. Okay, the string address. Put it here. So the next time when you call it, you put in now. But this global variable knows that previously you talked about that string. Okay, I know that I should continue with that string. So this is the problem, and we call it string. Thread safety. And this thread safety is a very well-known problem that every operating system has to fix it. You have to design something, okay? Maybe it is a library call, maybe even a system call that there will be a process calling you based on different threads. So you cannot rely on global variables that save inside the call. Maybe the global variable is malloc. It's just the same, okay? The malloc, because malloc is shared among different threads. So the problem, how to solve it? To solve it, so this is the illustration. The illustration is first, you write something. So input string from thread 1 will be kept in the data structure. Okay, so this is the first call. And next time, when this call start with the string token call for the first time, it will write the input string here inside this data structure. So thread 1 and thread 2 both refer to the same structure and will rely on the thread 2 data to start processing. So you only get one group. Okay, so thread 3, thread 4, thread 5, they all behave the same. I don't care how many threads you have, but as long as you share something, you have a problem. How to solve it? To solve it is not called string token. Okay, we are not going to modify string token implementation or your program, but let's take a look at the main page of string token. Okay, so this is the main page of string token. You find two functions, right? The first function you already know it. You already know it because you are using it in assignment 1. Okay, I don't blame any bugs. Okay, if you have some bugs about string token using string token, you cannot understand what happened. It's not because of thread safety, because you didn't use thread. Okay, Next, you find another call. Another call is very similar, and how similar it is. You have this first argument, same argument. Huh? Second argument is a delimiter. The delimiter of a character that you want to chop this into token. And these two are the same. The last one, you never see the last one, right? You don't use this. Oh, so what is the difference between these two guys? This underscore R has a special name. We call it re-entrant property. So what is a re-entrant property? Yeah, okay. So re-entrant property is here. You design another function, okay, so that the function never use this global structure. What's the meaning? You are afraid, okay? You should provide that storage to me, okay? Instead, the library call gives you the global storage. You provide the storage, so that every time you create this red box, don't call this again, okay? Because this will use global data structure. And based on this guy, okay? So let's highlight this, okay? Based on this little red box, it's only known to thread 1, or maybe it is a command log generated by the thread 1, or a local variable inside thread 1. So you pass into the new function called string token underscore R. Underscore R always expect that you will give us little memory for saving this bunch of things. Okay? So this is what we mean to make it become re-entrant. Re-entrant means that the function becomes stateless. Okay? Basically, the function is stateless. You call it, you have to provide the states. Previously, string token is a stateful call. You call for the first time, you know that I provide memory and store something, and next time you call, I base on what happened previously. So this is a stateful function call. Now it turns to become stateless, and you provide the state, feed this state into the function, and the function just take this bunch of data and take a look at data here. It's just the same for the string token. Okay? So that means you are taking in charge of the implementation of a string token. But don't worry, you don't have to provide the exact data structure like this. Okay? What you are going to provide is so-called a char pointer. Here. A char pointer. So what is a char pointer here? How to use it? I provide you an example. Okay? Let's pick with a syntax highlight. Okay. So you see, I'm using the string token. It's too high. Okay. I use the string token underscore R version. Okay, it's string token re-entrant version. And how to use it? The save pointer. I just borrowed the name from the man page. Man page was save pointer. I call it save pointer. And to use it, you create a pointer and pass it as an address to this guy. So that means this function wants to modify this guy. Okay? So that means the string token entire data structure only needs you to provide one pointer for it to save its states. Okay? So this is the state location, and when you call it every time, you just provide the same storage for it to modify. So this allows the function to modify the state, and that become normal again. So let's take a look. I just didn't change anything. I can provide you a div. Okay, div prefab string token .c prefab. Do you know what is div? How many of you don't know what is div? Okay, div is to compare two files, how different they are. Okay, so this is the what we call a div output. Okay, it is div output. So little. So you can see the difference is I just include a pointer I just changed this. This is only some new line changes. The string token call. Okay, the two file difference string token call, also a string token call. I didn't change much. Very few changes. Okay. And when you run it, yeah. Okay. So you will see two set of data coming up. Okay, two set of different data. Some are different, some are same. Okay, because they use some how can I say, the two strings share some common keyword. Okay, only the last and the beginning are the different. Okay, so you will see two bunch of things because they rely on two different set of data. Now, this is something good. And then you should ask me one question, okay, if you're following. Okay, seems that no one is following. This is conclusion now. You should ask me one question. How many function calls are thread and safe? Yeah, you should ask this question, or it will like a disaster. Okay? It is kind of a guarantee, okay? When people know that they are threading, we will implement all the function called thread safe. Okay? So you may ask this question, hey, yeah, very important question, huh? Is malloc thread safe? If malloc is not thread safe, there's a big problem, right? And it's normal, right? Because malloc controlling the share data range, right? It must keep something in a share area. Is it? Stack Overflow, someone already asked this question. Is malloc thread safe? Okay, don't worry, yeah. Don't worry, yeah. If you compile the code normally, okay, when you compile the prefetch program, you will add -l prefetch, and it will be thread safe. Okay? And to your surprise, there is one more thread unsafe function. Really a surprise. First time I know it is, I asked, why is thread unsafe? No. Chapter 3. Can you see two function call? Whenever you see underscore R, that means the non-underscore R version is thread unsafe. The underscore R version is thread safe. Can you guess what happened? What is the meaning of thread safe and thread unsafe this time? Do you understand what is the design of the pseudo random number generator?
You place a seed and then generate repeatedly.
Okay, but do you know that there is an equation behind it? Okay. Main random. A pseudo random number generator. Okay. Where's the equation? Should be somewhere. Okay. So pseudo random number generator is implemented something like this. Okay, it is a kind of a simplified implementation. So what can you say about implementation? The implementation is the next is being returned, right? And every time the next is depends on your last call. And can you find the next in the function call input? Where is that? Where is the next? Yeah. Global variable. Where is this global variable? So people think that, yeah, it's thread unsafe. Why? Because it's based on something global without any protection, and multiple threads can modify that when you call red. Okay? So people consider it as thread unsafe. So maybe you don't care, but some simulator really depends on the behavior of the random number generator. So it will forget about this call and use the re-entrant property. Now this means that it will keep the current seed and save in your thread local data. Okay, so this is your thread local data, and keep the seed. Next time it will go to the next position so that the thread Okay. So the thread will update the seed, okay, and that seed is only local to your thread. Maybe you don't need such a crazy idea. It's really crazy, yeah. But my program already demonstrates this big problem. So what's the big problem? My program, this program, okay. Actually, this program I'm using, I can use random here to choose random sleep, okay? If I choose random sleep, then you will usually use the thread at the same version. Then you will have some strange sleeping behavior that is not totally random, okay? But no one care. I know no one care. So this is it about pre-thread and also any other thread. Any other thread had a thread safety problem, okay? And the case becomes worse when you go to write things like Java, like C#, because you may create your own call, own function call. And your own function call rely on some object. And what is object? Object is global, okay? So whenever you write something like this, use Java, use C#, then you will have a problem that automatically you have thread safety problem, okay? So whether you want to encounter it or not is totally based on your point of view. Whether you want to say, I know that I don't want to change the object data, okay? I may need to copy 2 pieces, okay? So that one is keep on each thread. And synchronization mutual exclusion is all being an important topic. So this is the end of this chapter. This chapter we go through a long journey, very long, 10 weeks to cover it. Okay, we only have 4 weeks left. I am sure that all the later 4 weeks will be enough because other topics is relying on this big row. Okay, the big row here is we start with basic system call, and next time kernel system will also start with basic system call. Then you will go into the kernel to take a look what happened, and when you understand the kernel working, then you will understand, hey, actually you have to schedule the process, and at the same time some sidetrack. You will have some signal to interrupt it. What happened to the sound? Huh? Is it because I didn't turn off this mic? Oh, yes, I'm turned off. Okay. So then you have scheduling, and based on the scheduling, because we have different processes running together, IPC is a special topic that if, let's say, I only allow one process running at a time, if you have plate doors, okay, then you understand what I mean. There's only one process in this world. But now, it is multiple process, so we have IPC control, and we go back to the user land, the user level code that touch the threading. Okay, so this is a long story. Let's go to the next story.